In what ways can a question that involves the total area of a cone formula be made a little bit more tricky and have some extra steps? Here's one of them. In this situation, we are given the slant height and asked for the total area, but we are not given the radius. Instead, we are given the area of the circle that is at one end of the cone, and that area is 113.04 meters squared. We can use the area of a circle formula, area equals pi r squared, to solve for r. If we replace the a in this formula as 113.04 and replace pi with 3.14, r squared is our unknown. Dividing both sides by 3.14, these cancel. R squared is isolated and is equal to 113.04 divided by 3.14, which is 36. If r squared is equal to 36, r is equal to the square root of 36, which is 6. We can now plug into the total area of a cone formula. AT is our unknown, pi is 3.14, r is 6, s is 11, and the other r is also a 6. First we do 11 plus 6 and get 17. Six times 17 is 102. The total area will be 3.14 times 102, which is 320.28. And because our area unit is meters squared and our distance unit is meters, this is an area, the unit will be meters squared. Another way in which a question can be asked that involves the total area of a cone, but which forces us to do an extra step and makes the question a little more tricky, is illustrated here. We are asked for the total area. We are given a radius of 9 centimeters, but we are not given the slant height. Instead, we are given the height of the cone, which is 12 centimeters. The height is the distance of a line that can be drawn from the vertex of the cone straight down to the center of the circle at the bottom of the cone. That line would form a right angle with the radius, and it creates a right triangle situation. So we can use Pythagoras' theorem to find the slant height. We have to be careful because of the use of the variable h to represent the height, but h also represents the hypotenuse of a right triangle. So we have height here and we have hypotenuse there. Plugging into the Pythagoras theorem formula, we will make the radius our side A. So we have radius of 9 squared plus the b, which we will make the height, 12 centimeters, squared equals hypotenuse squared. Now we can solve for the hypotenuse. 9 squared is 81, 12 squared is 144. 81 plus 144 is equal to 225. But we need h, not h squared. If h squared is equal to 225, h is going to be equal to the square root of 225, which is 15. The hypotenuse of the right triangle is 15 centimeters in length, and that means our slant height is 15. Plugging into the total area of a cone formula, we get total area equals pi 3.14, r, which is 9, times s plus r, which is going to be 15 plus 9. Fifteen plus 9 is 24. Nine times 24 is 216. And 3.14 times 216 is 678.24. The unit of measure for distance was centimeters, and so for area it will be centimeters squared. The total area of this cone is 678.24 centimeters squared.